Hello everyone. Am I audible, guys?
Yes, sir. Hello, sir. Good evening.
Hello, good evening. Okay, let me share my screen. So last we have seen the static instance and local variables. Any doubt on this? So blocks also three types. Instance initialization block, static initialization block, and local block. Similarly, like variables. Okay, this is the second member of the class. Members of the class we are seeing in the template. What are the members you can use? Variables, blocks, constructor, methods, and inner class, right? In that variables we have seen. Next is blocks. Similar like variables, blocks is also of three types: instance, static, and initialization block. And block declaration in class, how we will define is, say class ABC, some class. Inside the class, this is a class block, right? From here till this is the block of the class. Inside the class, inside the template, you just put this is one block. Okay, it can be like this in these sum statement. Some statements, this is one block. You can have multiple blocks. This is another block. Okay, if you are starting the block with the static keyword, static, and then block, then this is a static block. Okay. Inside this statements, and you can have multiple, any number of static blocks. Next, local block. Okay, so static initialization block and instance initialization block. If you just define a block, that is instance initialization block. This one instance initialization block. Static initialization block is start with a static keyword, and that will be static initialization block. Next is local block, right? Local block is similar like local variable. Local variable is what? Inside the member of the class. Inside the member means inside a block, if you write another block, that will be local block. Inside the block, you declare a variable, that will be a local variable. Same way, inside the constructor, you declare a block, it will be a local block. Inside the constructor, declare a variable, that will be local variable. Same inside the method, you declare a variable, local variable, declare a block, that would be a local block. So this is an instance block. Inside this, if I declare a block, then this would be local block. Local block, right? You can have multiple local blocks in the same location like this. Or inside the static block also you can have local block. Okay, then static local block is nothing is there. This is a block, static block, inside that a local block. You can have here also another local block, or you can say take a method, say void show info, like yesterday how we took. Inside this, if I take a variable int ab, then this is a local variable. You take a block, that will be a local block. Local block, right? Like this, the block. Like this. Now we'll come to local block little later. Come to instance and static. Instance and static initialization block. So let us take an example. Test. This is 69. We have not executed actually. Then 70. test 70. And in this is the main method and class ends here. Okay. Say class hello. Inside hello class, I am taking a static block first. I'm just saying here static initialization block. This is the output. You can have multiple. Okay. First, let us take another instance block. This is the instance initialization block. Instance initialization block. Similarly, you can take more. This. I'll say static initialization block 1, instance initialization block 1, static initialization block 2, instance initialization block 2, like this. Okay. So that's it. These are the blocks, instance and static block. Now let us create an object I follow. Currently no variables in this, but just let us create an object. So I'll say hello h1 is new hello, right? One object is created. That's it. Now see the output. Compile test 70. Test 70.java and execute. Test 70. Unsupported. Right, that is fine now. And not here. Okay. Java C test 70 and execute. Right now, see static block 1, static block 2, instance block 1, instance block 2. Okay. Now, what is the order? First one static block, then one instance block, then one instance block, then another static block, then another instance block. But at the time of execution, static block 1 and static block 2, then instance block 1, and instance block 2, right? First, all the static block. Okay. This was how it was executing. Okay. First, both the static block, then instance block. Okay. Let us create another object. H2. Now see the output. Compile and execute. Static block 1, static block 2. Instance block 1, instance block 2, instance block 1, instance block 2. So how it works? Why instance block 2 times? Both the instance block 2 times and static block once because of the execution flow. Okay. So how we have seen last class, JVM works similarly. See the diagram again today. So JVM will start and it will request the memory from RAM, got the memory divided into 3 part, and first part, second part, and third part. First part is method area, stack, and heap, right? So when you say Java test 70, this is test 70 class loaded, and in that it has a main method. So main method starts execution. This is main method till this. Inside the main method, first statement, h1, hello h1, just h1 memory will be allocated inside this local, and this is h1, the size is 8, right? And when you say new hello, it will check in the method area anything with the name hello, not there. So hello class will be searched in your workspace. Hello class is found, hello class will be loaded. At the time of loading, this is hello. At the time of loading, static variable, as we discussed in last class, static variable has to be searched, but currently no static variable. So first it will check for the static variable, no static variable found. So then it will go for the static block. So first static block. And in these, nothing is there. It will just print this statement. It will print here static initialization block 1. Done. It will check any other static block. Okay, another static block. It will just print that static initialization block 2. Okay, done. So this is class loading is over. Okay. So at the time of loading the class, JVM will search the entire class for a static variable first. No static variable found. If a static variable is found, for that memory will be allocated at this place. That will be initialized with the default value. Not found, then it will go for the static block verification. Throughout the class, what are the static blocks available? Okay, first static block, it will be executed that one. Then another static block, it will be executed that one. So both is printed here. Okay, and notice in which order a static block is declared. So first static block is coming first, then second one. In which order it is declared is you have implemented in the class in same order the static block will execute. And once that execution is done, done, then class loading is over. Once class loading is over, the object has to create. Object will be created in the heap. This is the object. At the time of object creation, check the entire class for instance variable. If instance variable found, memory will be allocated in this, and that will be initialized with the default value. No static variable found, then go for the instance block. This instance block. Instance block is just having a SOP statement, so it will just write instance initialization block 1. Any other instance block, you have one more, instance initialization block 2. So it will print instance initialization block 2. This one will execute. So no other instance block, so object is ready, no other work. This address will assign to, say this is 1040, this will come into 1040. H1 is pointing to this object. Okay. So this is the first object creation. This statement is over. Next, come to second statement. One H2 memory. This is H2. H2 size 8 byte. Then go to the next new hello. It will check in the method area. Hello class is there. It is there. It will not load again. Since it is not loading again, so no checking for a static variable, no checking for a static block also. Okay. Because of this reason, a static block is only once. So class is there already. It is no need to load again. Now come to the object. Object will be created. This is the object creation. Now at the time of object creation, search the entire class for instance variable. No instance variable. Okay, go for the instance block, first instance block in the same order how they are defined in the class. So again, it will print instance initialization block 1 and instance initialization block 2, right? So that is done. Now address of the class 2080, address of the object will be assigned to H2 2080. This will point here, done, over. So this is over. No other statement in the main method. Everything will be destroyed. Memory will be returned back to the main method. Because of this, the output is like this. So from here we understood this object. This is the object, right? This is the object. It is also called as instance. Object is also called as instance. Okay. So instance block will be executed with each instance creation. You create 100 instance, 100 times instance block will execute. The static block will execute at the time of loading the class. At the time of loading the class. So how many times class will be loaded? Only once. So in static block will execute only once. This is static initialization block execution flow and instance initialization block execution flow. Now come to next. What is the use of instance and static initialization block? Why these are required? Take a class, another test. Test 71. .java. In this test 71, this is the test 71, and in that one main method. I have this class hello, but I'm not using it. Okay, it is just defined here. I'm not using at all. So in these now, if I take int a variable declared and a is equal to 99 initializing, and after that print line a, right? That's it. Hello, I am not using at all. This is not there. Assume it is not there also, like this. Okay. So it will print 99. That's it. Very simple. Test 71. And execute. Test 71. It is 99. That's it. Simple. Now, if I take a class ABC, inside the class, I'm declaring a variable int a, not initialized, and a is equal to 99. Now what will happen? Compile test 71 again. Not okay. It is saying at this point, identifier expected. Message is not specific very. The thing is, inside the class, you can write only these 5 statements. Inside the class, you can have only these 5 members. Other than that, you cannot write a SOP system.out.println statement, or you cannot initialize a variable also. This initialization is not okay. Okay. This is not a valid statement in the class. It is not a variable declaration. It is variable initialization. So this is not okay. But if you initialize here itself, then this is fine. Okay. Instance variable declaring and initializing is fine. But in these, this is not correct. Okay. This is not correct. So assume my requirement is like this. I want to declare a variable here and I want to initialize in the next statement. It is not possible in case of in the class. In the class, it is not possible. So what you can do, you can put this inside a block. So now this is valid. Okay, now this is valid. Compile it. Test 71. Okay. And I'll write a SOP statement. So I'll say it is a printing, and this is some one, this value. Okay, now compile ABC. Sorry, test 71. It is compiled, but this statement will not print. If I execute, it will not print. It will just print 99 because I am not using this at all. Currently, ABC is not used. So if you execute test 71, it is just 99. It is not printing this statement. When this statement will execute, if I create an object, so ABC A1 is new ABC. Now if you compile again, test 71 and execute. Okay, it is this. It is coming from here. Object is created and this is printing this statement. Okay, if you create another object, it will print again A2 and compile. Test 71 and execute. Okay, so it is like this. Now in this, how the memory is working. What is the memory in this case? Say this is method area, stack and heap memory. Okay, stack and heap. Okay, so test 71 will be loaded. This is test 71. Main method started execution. This is main. From here till this, and inside the main method you have a local variable. So this is a, then a is 4 because it is int, and the value in the next statement, first time it will not get anything, not even 0, because local variable will not be initialized by JVM, so it is be empty. In the next statement, a is initialized with 99, so this is 99. In the next statement, printing a will be printing 99. Next, ABC, A1 will be allocated. This is A1, size is 8. Now new ABC class has to load. This has to load. Loading ABC loading. In that, no static variable, no static block. So loading is over. Now come into the object. An object will be created. At the time of creating the object, all the static variables, you have one. This is A. I'm sorry. A memory will be allocated. Get the default value 0. No other instance variable. So come into the instance block A, which is already initialized 0. That will be initialized with 1, 1, 1. Okay. Now printing A. This statement, okay, initialization 1, 1, 1. Which A? It is the same A. Same A we are initializing. Okay. So that will be initialized with 1, 1, 1. And printing 1, 1, 1. This is statement. At the time of object creation, this task is done. Now address object is also ready. Address of the object 1040 will be here, 1040, this points here. This is first object ready. Come to the second object, A2. Now in case of A2, class is already loaded. ABC object has to creating the object. At that time, instance variable A memory got allocated. Default value is 0. Now instance block, again A has to initialize this A, okay? This will be 1, 1, 1. And now print A, again 1, 1, 1. So this statement executing twice, because we are creating two objects. And you remember this A is from two different objects, not in the same object. Two different object A value is printing and both is 1, 1, 1. So now from this you understood why we need the instance initialization block. Instance initialization block we need to initialize instance variable, because directly we cannot initialize. In the block, in the instance variable, if we want to initialize with some value, then in the direct statement we can do, but in next statement is not possible. So to do that in the next statement, we are doing that inside the initialization block. Okay, initialization block. Okay. Now why it is okay. Similarly, if we have a static variable, and a static variable also we cannot initialize in the same statement. In the next statement we want to initialize, then you will go for static initialization block. So assume I have a static variable int b. B I don't want to initialize here. Where I want to initialize? I want to initialize in the static block. And inside this, b is this. And I'm printing b also. And this is okay. So this is a static initialization block. When it will be executed? At the time of loading the class. At the time of loading the class, it will search the entire class for a static variable. So we have one static variable b. This b memory will be located here. Default value is 0. Then it will come into static block. B is initialized with 222. So this will be 222. And now printing b. This will be here in between. So this will be like this. And after that, object you are creating. This is for one object. This is for second object, A2. So this is why we use instance and static initialization block. Instance variable, to initialize the instance variable, we use instance initialization block. To initialize the static variable, we use static initialization block. Multiple block you can use. Now, if we execute this, then the output should be 999992222 and 111 two times. Compile test 71 again and execute. This is the output. Okay, this is the output. Next, why this is like this? Why A we are initializing in next statement? Why not here itself? If we write here itself, this is okay, no problem. Same thing. This, instead of taking a B static block, we can write here same, right? Then these things not required to execute. These only is enough. Now why we need like this? Because currently this is just a simple variable primitive type we are initializing like this. But assume it is not this type of variable, it is a connection. It is a connection type variable, and connection type variable I want to initialize with some connection value, that too with a database connection. Assume this connection variable not a normal value. This I want to initialize the database connection. Oracle I am connecting from my application. Now this is not a one line of statement. I cannot just write something here and it is not going to connect with Oracle. Okay, it is not that simple. To do this operation, we need some set of statements to execute, and finally we will get the connection value. Finally we will get the connection value here, and then we can initialize. So those statements inside the class you cannot write, because those will not be a member of the class. So assume before getting the value of this connection, I need to execute some 10 more statements. And after executing those, I am going to get the connection value. So those statements in the class or in this line, you cannot write directly. You need to initialize somewhere. So that somewhere is the block. Okay, block. Similarly, for case of static, also assume it is a network connection I want to do. So to doing a network connection, so many verification, validation, so many things we need to do, and after that we can get the connection. So those statements you cannot write in the same statement here. so that he cannot write, he can write inside the static block. Okay, use of instance and static initialization block. Right. Remember, instance initialization block is to initialize the instance variables. Static initialization block is to initialize the static variables. Instance initialization block will execute the number of time you create the object. 100 object you create, this is going to execute 100 times. Static block will execute only once at the time of loading the class. If you have multiple instance and static blocks, all will be executed in the same order in which order they are defined in the class. Okay, in which order they are defined in the class. Another important point you remember. Okay, currently it is till this done. Next is next is take another example. Test 72. .java. And in test 72, these are the things I'm not using, so deleted, just A and B. And in these, one instance block, this one static block, and printing the static. Okay, that's it. But the variable declared is not here. Variable is after the block. Okay, after the block. This. And in these, A is equal to 99. And here, B is equal to 88. And after that, after the variable, again, I have two more. Not initialized. No. And I'm saying here A instance initialization block 1 and the value of A. Okay. Instance initialization block 1 and the value of A. Similarly, instance initialization block 2 and the value of A. Static initialization block 1 and the value of B. Similarly, this static initialization block 2 and the value of B. Now, how will be execution flow? What it will be? Very, very important. Okay, remember this. And in the class, what we are doing? I'm just creating two objects. Okay, just creating two objects. That's it. Okay, class ABC in this one. Now, how it would be in the case of execution? Very, very important. You remember this. So when we will start Java and test 72, JVM will request some memory from RAM. Memory will be divided into multiple parts. Method area, stack memory, and heap. Method area, stack, and heap. Okay. So first test 72 will be loaded. 72. Then main methods start execution. Main. And inside the main, first A1. Remember, okay, for the reference variable, class will not be loaded. Class will be loaded only when you create the object. So A1 is a reference variable, A1, that's it. Till then, class will not be loaded. Now it will come into this part, new ABC. Then it will check ABC class is loaded, not loaded. ABC class will be loaded. ABC. At the time of loading the class. Now, it has static block first, then the static variable. What will happen? Then In this case, it should say here that B is not available because till then B is not declared, but not like this. First, only throughout the class, static variable will be searched. Okay. So if the static block is coming first or instance block is coming first or whatever, whenever you declare a variable, no matter, first it will search the entire class for static variables. So static variable is found B. B memory is allocated. This is B, 4 bytes of memory, default value is 0, done. No other static variable, fine. Then again from the beginning. So searching in the class will be from top to bottom, okay? First throughout the class, check the static variables. One found, allocated the memory, initialized the default value. Now, again from the beginning of the class, static block. It will come into the static block and it will say here static initialization block 1 and the value of B. What is the value of B as of now? 0. It will print here 0. Okay. Then B initialized. B value is changed to 8, 8. Now next static block. Where is the next static block? Next static block. In the next static block, static initialization block 2. Static initialization block 2. B value. Now B value is updated in the first static block. So B value is 8, 8. It will print here 8, 8. Okay. Now you notice when the time of loading the class, throughout the class, it will search the static variable first, allocate the memory for those, initialize the default value. Then from the beginning of the class, again, a static block will be searched and it will be executed static block in the same order how they are defined in the class. So first time here the value of B is 0 and next time the value of A is 8, 8 because it is updated in this. Remember another thing, wherever you declare the variable, this variable is declaration at this point, but it is using before the declaration. No matter, it is not a problem. Inside the class, when you declare a variable, variable is accessible throughout the class. Wherever you declare it, it may be at the beginning, it may be at the end, no problem. Variable is accessible throughout the class. And why it make possible? What it make possible? Because it is searching the variable throughout the class at the beginning and allocating the memory for that first. Then it will go for any other operation. Because of this reason, any variable declared inside the class is accessible throughout the class, even before the declaration statement. Okay, even before the declaration statement, the variable can be accessed. Next. So class loading is done. Class loading is over. Now come to object creation. When you will say new hello, new ABC, then ABC class loading is over. ABC object has to create. At the time of creating the object, search throughout the class for instance variable. This is a variable. A memory will be allocated. The value of A will be initialized with 0. Next, any other instance variable? No. Okay. Go to the beginning for instance block. This is the first instance block. So it will print here instance initialization block 1. And the value of A at that time is 0. It will print 0. Now A is updated. A is 99. This value will be 99. Now, next instance block, this one. It will print instance initialization block 2 and the value is 99. Over. The memory will be here. First one is done. In case of second one. Now A2 memory will be allocated. This is A2, size is 8. Now, come this part. Class is already loaded, so that is not going to execute again. Object has to create. At the time of creating the object, throughout the class, search the instance variable. A is found. This is A memory, and initialized with 0. Now, no other instance variable. Come to the instance block. It will print this. Instance initialization block 1. And the value of A at that point for this instance, okay, for this instance is 0. Next, A is updated to 99. This is 99. Now, next instance block, this one. Instance initialization block 2, and the value is now 99. Now notice again, for instance variable also, that it is accessible throughout the class wherever you declare. Okay, wherever you declare, it is accessible throughout the class. Even before declaration statement, you can use this. Okay, even before declaration, you can use, because it first scans the entire class to get the instance variable. So wherever you declare, it is accessible throughout the class. So this should be the output if we compile and execute this. Compile this one, test 72. test72.java and forward reference. Okay, illegal forward reference, one problem, but what you can do is, this is giving for this one. Okay, I'll just currently use here this, and for this I'll use, I'm coming to that, what will happen in this case. Okay, ABC. Now compile it. Okay, and execute. Test 72. Test 72. This is test 72. We have not updated, so this is the issue. Compile again. .java and execute. Right. So static block 1 value is 0. Static block 2 value is 99. It was updated. Static block 10 299 10 299. So this is the same output, right? What you say. So this is the execution flow, but it has a problem. This one, this dot illegal and this. Okay, we'll come to that. What happens in this case when we'll go to this keyword, okay, separately. Currently assume this is just the output. So this is instance initialization block and static initialization block. Any question till this? No, right? Okay, if not, then we'll go to a local block next. Local block is inside a block if you declare another block. And take another example. Test 73. I have just a symbol this. And currently in this, the string MSG is hello and println MSG. That's it, right? It should print just hello, nothing else. Test 73. Test 73.java. Test 73. Okay, it is just printing hello. What if before this I am printing here? Okay. Now what will happen? Before declaration, like instance and static variable throughout the class, but in this case it is not okay, cannot find symbol. Test 73, it is cannot find symbol MSG. MSG is not available. Why? Now this is a local variable, okay, local variable, and local variable we have seen before also. In case of for loop, this is a valid for loop, right? Infinite loop it will be. And inside this, if I declare a variable some int AB and initializing that with something, outside this loop you cannot access it. We have seen that, right? We have seen in for loop we have seen that, or while loop, or in switch statement also we have seen. So the variable you declare inside a block is accessible only inside the block. Okay, outside you cannot access. Okay, so that would be a local variable. Similarly here, this variable is a local variable for the main method. Okay, or if you take a class hello, inside the hello class, like we have seen show info in previous class. Inside the show info, we are printing the variable something like this, right? So we have it was a student class, student, and in this int sid string type name. So in show info, we are printing println sid plus one tab space and name. Okay. So these accessible throughout the class. If I take it from here and if I put it down, this also will work fine, no problem. But in between here, if I take a variable here, say int ab, and if I say it is 99, then this is a local variable for this block and is accessible throughout the block. Outside the block, this is not visible. But it has a problem. What is the problem? This variable is accessible. If I write here, 1 minute, guys. Okay. So if I'm writing here and this statement at this point, say I'm taking another tab space and printing AB, then this will work fine, no issue. This will work fine. But if this statement is below this, and if I write this, now the accessibility of this AB is inside the block, right? Block is here, but it is not exactly okay. This is now this will say cannot find symbol. Similarly, like this, cannot find symbol because the local variable scope is inside the local block, but not the throughout the block. This is after the declaration statement. After the declaration till the end of the block, accessibility is there. So if I put this statement at this point, from here, from the declaration statement till the end of the block, this AB is visible, accessible. Before the declaration statement, at this point, if I try to access AB, it will say cannot find symbol. Similarly, like this. Okay. So local variable scope is throughout the block, inside the block, but not throughout the block. It is from the declaration of the variable till the end of the block. Okay. The local variable scope is from the declaration of the variable till the end of the block. So this can be accessed at this point, but here it is not accessible. But it is throughout, it is till the block, till this you can access it. Before that or outside that, it is not accessible. Okay. So this is the accessibility or scope of a local variable. But in case of instance and static, we have seen throughout the class, wherever you declare it throughout the class, you can access it. Remember this, it is very, very important. Next is, okay. Now this should work fine, right? Where is SID and okay, SID and this, okay, here. If I compile, it should work fine, but it will just print hello because we have not done anything else in it. Compile test 73 once. Test 73, it is okay. And execute test 73. It will just print hello. Okay. Means this is also compiled. This is also compiled. So these statements are valid. If I put this statement below here, then it will say cannot find symbol at this point. Okay. Next is local block. Take another test 74.java. This is test 74. So local block is, I'm not taking this, just if I take a block here, then this is an instance block. If I take it like this, static, then this would be a static block, and this is a method. You can take a local block inside an instance block, inside a static block, or inside in a method also. Okay. Now assume system.out.println. This is instance initialization block. That's it. And this is static initialization block, and this is show info method. Okay, like this. Now inside the instance initialization block, I have a local block. I'll say this is a local block. Local block in instance initialization block. Okay, similarly local block inside the static initialization block. Local block in static initialization block, like this you can take, or local block in show info method, like this, like this. This is not required now. So inside this main method, I'm just saying student S1 is new student. Again, student S2 is new student, right? Like this. So a static block has to execute once, instance block has to execute twice. Okay. So now when a static block is executing, this local block inside the static block also will execute. When instance block will execute, inside the instance block, this local block also will execute. Means local block should be executed twice from instance initialization block, and local block in static block has to execute once at the time of loading the class. Now you compile test 74 and execute. Okay. Static block and local block in static block. Local block, instance block, and instance local block in instance block. Instance block, local block in instance block. But show info inside that also one local is there. It is not executing. Why? If I am not creating the object, then instance block also will not execute. Okay, because local block is will execute only when the member is executing where the local block is defined. Okay, local block will execute only when the corresponding block will be executed. So if I want to execute this local block, I need to execute show info, then this block will be executed. Now if I call here s1 dot show info, then in show info local block also will be executed. It will show info and local block in show info. Compile it and execute. Okay, show info and local block is in show info. Okay, so local block, from this you understood when the local block will execute. Local block will execute when the corresponding block where the local is defined will execute. Okay, now why local block is required? Why local block is required? Local block is required because if I declare a variable here int a is equal to 99, then this is accessible till the end of the block. Till the end of this location, a is accessible. But I don't want this. I want a should be accessible only till some point. So what you can do, you put a in a block, in a local block. This. Now, this a is not accessible at this point. Okay. If you say here plus a, it will say cannot find symbol. Compile it. Test 74 cannot find symbol a because it is inside the block. But if I don't give this block notation, now it is accessible in this also, because from declaration point till the end of this block where it is declared, till this, now it is okay. Compile it. Test 74. Now okay, and it will work fine. Execute. 99. So If you want to put a restriction of the local variable, then you can go for a local block. The use of local block is to put a restriction to the accessibility of local variables. Local block is used. When local block will execute only when the location where the local block is used or declared will execute. At that time, corresponding local block will execute. Okay, we understood three types of block: instance, static, and local. Instance block will execute at the time of class loading. Instance block is used to initialize the instance variables. Sorry. Static block will be executing at the time of loading the class, and static block is used to initialize the static variable. The order of the execution in the same order how they are defined if you have multiple static block. Static variable is visible throughout the class wherever you declare it. Similarly, instance block will execute within each instance creation of the class. Instance block is used to initialize the instance variables. Instance variable visible throughout the class wherever you declare. Instance block, if you have multiple instance block in the class, those will be executed in the same order how they are defined. Local block will execute at the time of the block where the local block is defined, will execute at that time. Local block uses to restrict the accessibility or scope of local variables. So this is three types of blocks. Any question? Blocks. No question, right? Very, very important point you need to remember. In OOPS concept, whatever we will define, we will discuss in the class, you must be very clear with those, okay? Because in the next class or each other next class, throughout the course, you need to use that, not throughout the course, in your entire life. Okay, if no question, we'll close here today. Tomorrow we'll see next. Thanks everyone. Bye-bye.